to break down another math concept. This time we are factoring polynomials by greatest common factor. Very, very important. Every time you are factoring polynomials, you must first see if there is a greatest common factor that you can pull out. So keep in mind, we will always factor by greatest common factor first before we go into any of the other ways to factor. Let's review a little bit. How do you find the greatest common factor of two integers? First, you list all the factors, and then you find the greatest factor that is the same in both. I've listed all the factors of 12 and 32. You will notice we have a common factor of 2, and we have a common factor of 4. Therefore, the greatest common factor would be 4 because it is the largest common factor. Now, how do you find GCF with variables? Find all the common variables that are in each term, and the GCF will have the smallest power. Let's find some. Okay, I look all the way across and I see an x, so therefore the common factor of x is there. I don't see a y in my first example, so therefore y is not in the GCF, only x is. And if I look at all of my exponents on the x, I have a 3, a 4, and a 2. The smallest power is 2. Therefore, the GCF is x squared. Okay, this time we do have a common x and y in all of the examples. You'll notice if you go across the exponents of the x, the smallest x power is x squared, and the smallest y power is y to the first power. When we factor by GCF, we divide each term in the polynomial by the GCF using the quotient rule of exponents, and then we simplify any integer coefficients that we might have in the front. We pull the GCF to the outside. We follow the GCF by the remaining terms after we divide it in a set of parentheses. Some people refer to this concept as reverse distributive property. And the good thing about that is if you perform the distributive property to your answer and you get the polynomial you started with, then you know that you factored it correctly. And again, before you factor any polynomial, check to see if you can pull a GCF out first. Okay, let's look across the top, and I notice that we have a common factor of 3. We also have a common factor of x. Therefore, our GCF is 3x. So I'm going to divide every term by 3x. If you divide by 3x all the way across, you get x to the third minus 3x squared plus 5x minus 4. How do we write it? We put our GCF to the outside, and then we follow it by what we got after we divided it in a set of parentheses. The answer's in green. Okay, let's try another one. I look across there and I see a common x. I don't see any common coefficient except for 1. We don't use 1. So the common x and the lowest power is x to the first. So I divide all of my terms by the GCF of x, and I will get x to the third minus 2x squared plus x minus 5. I pull my GCF to the outside and put what I got to the inside. Final answer. Okay, on this one, you'll notice there's not an x with that 6, so therefore I don't have a common x, but I do have a common factor of 2. So I will divide all the terms of my poly by my GCF, and I will get 6x third plus 3x squared minus x plus 3. I pull my GCF to the outside, and what is left goes in parentheses inside. Okay, here's one with two variables. You'll look across there, and we do have an x and a y in all the terms, so therefore we will use both. And then you look across there and find your smallest power. Therefore, we get x squared and y to the first. So I divide every term in the poly by the GCF. I'm using the quotient rule here. Remember, with quotient rule, we subtract the exponents, and I will get x to the third minus x squared y to the third plus xy minus 1. I pull my GCF to the outside, and then I'm left with that on the inside. Thank you for watching all about factoring polynomials with GCF. Be sure to hit that subscribe button, and you will learn about new and exciting ways to make math easy.